Hi students, welcome back. In this video session, we shall continue from where we stopped in part 1. So please, this is the second part of the video playlist on normal probability distribution. It is highly recommended that you view it in order. You view the videos in order. So you view the first part and the prerequisites to that first part before you continue with this video. So we are going to use the left shaded area as usual, the normal probability distribution, the standard normal probability distribution table, left shaded area. So please, when you click on probability distributions, view the videos you see here in order, please, so that you can have a good understanding of it. So we looked at this in the first video, and we are still solving problems on MATLAB. Okay, we are going to use what we used in the first part of the video, left shaded area, the standard normal distribution table, left shaded area. So question 8 is the next question, and I will pull up my notebook. And I will add a new page here, finding part 3. I will just say normal distribution part 3. In my notebook. Okay. Here we are being asked to find the z-score. They gave us the area already. Okay, the area or the probability, and this is towards from the left. So the area is 0.9535, and they want us to find the z-score. So we look at our table. Let us look for 0.9535. So we look for 0.9535. We come here, 0.9535. So you see, this is 0.9535 right here. Then we now look at the z-score for that, and this is 1.68. 0.9535 is 1.68. 1.6 here plus 0.08. Okay, that is how we got the 1.68. Let me show you. We talked about this in the first video, but I will show it to you here. So this is a 1.6 plus 0.08. That gives you 1.68. So you just come over here and you put it in. That's all. 1.68. Okay. Question 9. They gave you the area to the left as well, 0.2296, or you can say probability to the left. We talked about this in the first video. So what is the z-score? So we get our table, 0.2296. 0.2296, 0.2296. There you go. It's right here, 0.2296. And that will give us negative 0.74. See that? Negative 0.74. So I'm gonna put it here, negative 0.74. Okay. Question 10 Here they are asking us for the z-score for an area to the right. The area to the right is 0.8078. But however, the table that we are using is to the left. So, but we do know from the first video that the entire area under the normal curve is 1. So they gave us area to the right, but we are using the table to the left. We are using a table where the area is to the left. So what we can do is we subtract this from 1 because we don't have the table that gave us area to the right. We do have it though, but we don't want to use it. It's on these resources, but like we said in the first video, this is the table that we will be using. So what we could do to find the area to this right is, first of all, because we are given area, the table that has area to the left. So let's find that, let's subtract this from 1 and then look up the left, and that will be the z-score. Okay, so we go ahead and subtract this area from 1. 1 minus 0.8078. That gave us 0.1922. So we are now going to find this area here. We are not going to find the what the z-score for that area is. So let's say 0.1922. 0.1922. 0.1922. There you go. It's right here. So it is negative 0.87. Okay, negative 0.87. That becomes our z-score. Negative 0.87. Okay. Question 11, they gave us this area to the right. So let us go ahead, subtract it from 1 so we can get the area to the left. Then we find the z-score. Because we are using this table, because we are using the table to the left. So this is going to be 1 minus 0.1292. 1 minus 0.1292. So that gives us 0.8708. So we come over here, 0.8708, 0.8708. There you go. See that? So that is 1.13. 1.13. Okay. So we come over here, we put 1.13. Okay, question 12. Assume that a randomly selected subject is given a bone density test. Those test scores are normally distributed with a mean of 0 and a standard deviation of 1. So we said that this is a standard normal distribution if the mean is 0 and the standard deviation is 1. So it is the standard normal distribution. Find the probability that a given score is less than negative 1.75. So because this is already the standard normal distribution, we will go ahead. This is our z-score right away. Okay, and draw a sketch of the region. So this is the z-score and it's less than. For it to be less than, it's not going to be this because this area is greater than. This is less than, but this is 1.75. We are looking for less than negative 1.75. And we are using the z-score as this because this is the standard normal distribution. It has a mean of 0 and a standard deviation of 1. If it does not have a mean of 0 and a standard deviation of 1, then we shall find the standardized score first. We shall find we have a formula for that. So, but this is the standard normal distribution. So we are good. So this is less than negative 1.75. It will not be this also, because this is between. This is the area or the probability between negative 1.75 and 1.75. This one is less than 1.75. This one is greater than negative 1.75. But the question says less than negative 1.75. So you see that it's going to be this. So you take that. Now, what is the probability? We pull up our table and we go to negative 1.7 under 0.05. We talked about that in the first video. Negative 1.7, 0, 1, 2, 3, 4, 5. And that will give us 0.0401. 0.0401. So we do that. 0.0401. Okay. Question 13. It says here, find the probability that the given score is less than 1.69. This is less than 1.69, the area here. This is less than negative 1.69. This is the probability between negative 1.69 and 1.69. This is the probability that it is greater than 1.69. But they are asking us for less than 1.69. So that is this. And the probability will be we find this probability for the z-score of 1.6 under 0.09. So 1.6 here under 0.09 right here. See that? So that is 0.9545. 0.9545. 0.9545. Okay. Question 14. Question 14, this is still the standard normal distribution table because it has a mean of 0 and a standard deviation of 1 degrees Celsius. Find the probability that a randomly selected thermometer reads greater than 2.02. So this is this is greater than negative 2.02. This is less than 2.02, but this is greater than 2.02. Okay, greater than that. So we now look for this area here. Now, this is the area or the probability that we are looking for. But the table that we are using gives us the area or the probability to the left. Okay, so what we are going to do is we will find that to the left and then we subtract from 1 to get this area to the right. Okay, so we are going to find the probability or the area for the z-score of 2.02, which means 2.0 under 0.02. Whatever we get, because we are using the table to the left, it gives us just this area. Okay, this will be in page 2 of that table because that is for positive z-scores. We talked about this in the previous video. Page 1 is for negative z-scores and page 2 is for positive z-scores. So when we find because we are using this table, the area that we get is to the left, but they are asking us to the right. So we have to subtract that area from 1. So 2.0 we read this 2.0 under 0.02, 0.12, and that gives us 0.9783. 0.9783. So we have a 0.9783. Ooh, guess what? I didn't subtract from 1. Okay, remember, and I said it, but I didn't subtract from 1. Okay, let's subtract from 1. 1 minus 0.9783. There you go. 0.0217. Okay, 0.0217. Okay, so please take note. All right. Next question. Here it says greater than 1.57. Okay, greater than 1.57, and that is this. Greater than 1.57. Now, this is still a standard normal distribution table. The mean is 0. The standard deviation is 1. Okay. Now, the probability. Make sure now that you subtract from 1. Yes, sir. Yes, sir. Okay, we are going to read it, and we have to subtract from 1 this time. 1.5 under 0.07. 1.5 under 0.07. 1.5, 0, 1, 2, 3, 4, 5, 6, 7. So this is a 0.9418. 0.9418. So 1 minus 0.9418 equals 0.0582. So that is 0.0582. There you go. Okay. Question 16. Mean of 0, standard deviation of 1. So we are good. Anytime we say this, we are good. Mean of 0, standard deviation of 1. We are good. So find the probability of the reading between 1 and 2. Between 1.00 and 2.00. And that is actually this. Okay, between 1.00 and 2.00. Okay, you know, because you see that this is like this. If you guys want me to draw it. So you have the standard normal distribution table. Okay, it doesn't touch, take note. Whereby the mean is the center, and that is the 0. This is 0. And then you have the z-scores. Of course, 1 is greater than 0. Okay. 1.00. And then 2.00. So, remember, this is what we are being asked. And we did this in part 1. Remember what we did in part 1? Do you remember? In part 1, we did that. You find the first one, then find the second one, and you subtract. Okay? So, because this is like this, actually, let me explain it again here. So, because we are using this table, how do you find this area here? So you will see that this is the table they gave us to the left, right here. Now this is just the area we are asked about, okay? And we will have to find this area here using that table. So how do we have to do it? So you will just look at what I'm doing now. You will notice, you know, they gave you this. This is the table we use. And then you also find this here. 1. When it's 1, gonna be like here, 1.00. And you know, this is the way you do it if anytime you use this table. Do you notice that if you subtract this area here from this area, you will have this area? Do you see that? Assuming if you subtract this area minus this area, you will have this area. So that is the way we do it. Anytime we are being asked to find between using this table, that is what we do. So let us find the area for z equal to 2.00. So 2.00 under 0.00, and that is 0.9772. So we write 0.9772 minus, then we find for 1.00, okay? 1.0 under 0.00 is this 0.8413. So this is minus 0.8413. And that will give you 0.1359. 0.1359. So this is of course this, and then this will be 0.1359. Okay, that's it. Comprendez? Comprenez-vous? Do you understand? Here, mean of 0 degrees Celsius, standard deviation of 1.00 degrees Celsius. So we are good. We want to find between negative 2.06 and negative 1.49. Okay. So it is not this area, because this area is, actually this area is less than negative 1.49. This area is less than negative 2.06. So this area is the one in between negative 1.49 and negative 2.06. So you see, this minus this, look at this. This area minus this area will give you this area. Look at it. Okay? You say it, don't you? Let me speak like from the south. You say it, don't you? So, if you say something in the positive, then you ask the question in the negative. Then if you say something in the negative, you ask the question in the positive. You don't say it, do you? From the south, you say it, don't you? You don't say it, do you? Okay, so this area minus this area gives us this area. This is the area that we are being asked to find right here. Okay. Now, so let us find the area for, and you know, this is bigger than this, of course. Negative 1.49 is greater than negative 2.06, just like your number line. So let us find negative 1.49, the probability for this z-score, and also we find the probability for the z-score of negative 2.06, and we subtract it. Okay. So negative 1.49 here, negative 1.4 under 0.09, and that gives us 0.0681. 0.0681 minus, we look for negative 2.06. 2.06. Negative 2.0. Negative 2.0 under 0.06. 0, 1, 2, 3, 4, 5, 6. So that is 0 0.0197. 0.0197 minus 0.0197. Okay, and that gives us 0.0484. So we have 0.0484. Question 18. So the same thing here. We're gonna do the same thing here. Between negative 1.21 and 1.52. So this is the area we are being asked to find. Here is less than negative 1.21. Here is greater than 1.52. But this is the area we need. Okay, so we have to find the area for z-score of 1.52, and also we find area for the z-score of negative 1.21. Okay, and then we subtract. So 1.52 is 1.5 under 0.02, 0.12, and that is 0.9357. 0.9357, okay, minus, then negative, what is that again? Negative 1.21. Negative 1.2. Negative 1.2 under 0.01. So 0.1131. 0.1131. 0.1131. And that is 0.8226. Okay? 0.8226. Okay? Question 19. The mean is 0 and the standard deviation is 1. So we are good. Find the probability that the score is between negative 2.19 and 3.82. Here is between 2.19 and 3.82, but we are looking for negative 2.19 and 3.82 between. Here is actually this is pretty much kind of less than 3.82 is this one, less than 3.82. Here is between negative 2.19 and 3.82, and this is less than negative 2.19. So this is what we need here, okay? Now let's find the probability. 3.8 under 0.02. So we look for 3.8. So here you see 3.8 is not here. Okay, but this is sometimes you see questions like this. Now you will notice that 3.49 is almost 1, 0.9998. See that? Okay, 0.9998. And some university, some tables used in universities and colleges, they will kind of make a note here. They will make a note that if it is greater than so z-score, then take it as 1. Okay, but look at my advice here. If you don't see if it's greater than 3.49, just use 0.9999. How about it? Okay, use 0.9999. Now, we can still do this with technology, okay, but not in this video. Okay, later on I show you how to do these questions. This video is like we are using tables. Later on we will do technology, and the technology will include we talked about the technology in the first video. It will include StatCrunch, Excel, and Google Spreadsheet. These two cost money, StatCrunch and Excel. Okay, it's not free, but Google Spreadsheet is free. Okay, so in another video we shall do technology, but for now let's do this with table. So like I was saying, if you don't say it, if it is greater than 3.49, use 0.9999. So that is what we will use. 0.9999 minus. Now the next one is negative 2.19. Okay, so I'm gonna get negative 2.1 under 0.09, and that is 0.0143 minus 0.0143, and that gives you 0.9856. Okay, you put a 0.9856. Okay, question 20. Assume that a randomly selected subject is given a bone density test. Okay, mean is 0, standard deviation is 1. So we are good to use this table. So find the probability that the score is less than 3.84. Okay, so this is still the z-score. Anytime the mean is 0 and the standard deviation is 1, we call it the standard normal distribution table, and we are good by calling this, the z-score. So less than 3.84, okay, will be this right here, and the probability. Okay, now if you look at here, like we just said, if it is, if you find a z-score that is greater than 3.49, just use 0.9999. 0.9999. Okay, so that's what we're gonna use. 0.9999. Okay. Question 21. Now, percentile, we here assume that the readings on the thermometers are normally distributed with a mean of 0 and standard deviation of 1.00 degrees Celsius. So we are good to use the standard normal distribution table. A thermometer is randomly selected and tested. Draw a sketch and find the temperature reading corresponding to the 95th percentile. Okay, we talked about quantiles. So quantiles and box plots. So I did a video on it. Okay, quantiles and box plots, which you might want to look at later on. Quantiles and box plots. And this is the notes here. Quantiles. So we talked about percentiles here, which you really need to know. Okay, so percentile, decile, quintile, quartile. So if we talk about 95th percentile, okay, we are looking at the bottom 95th from the top 5. Okay, so because from here, percentile means, if you look at the formula, all the values less than x, okay, over total number of values times 100. Okay, we are looking at that. We are looking at it that way. Okay, so it's bottom 95 from the top 5. So we are looking at a less than 95%. Okay, which is 95% is 95 divided by 100, which is 0.95. Okay, 0.95. We want to find the temperature reading corresponding to this 95th percentile, or 0.95. Remember, we said in the previous video that area or probability or relative frequency, it could be expressed as percent or decimal or fraction. Okay, in this case, it's being expressed as a percentage, which is still 0.95. So we are going to find the z-score corresponding to this 0.9500. Usually we round areas to 4 decimal places, and we round z-scores to 2 decimal places unless otherwise noted. As you can see in this normal distribution table, the areas or the probabilities are 4 decimal places, while the z-scores are 2 decimal places. So if you look at this now, you will notice that the here is talking about greater than, so it is not it. Here is talking about less than, see that? Less than, and it's 0.95. 95% lower from the top 5%. So if you look at this, here it's talking about greater than, so it's not it. Now, so it's either B or D. But if you look at B and D, you will see that B has lower 95%, of course. This looks like lower 95%, so, from the top 5%, rather than this. This looks like 5% less than, lower 5%, and this looks like top 95%. So this is the answer here. Okay. Now let's find the z-score corresponding to that. Round to 2 decimal places as needed. Okay, so we are going to look at the area. We are going to look, and this is less than, so we are good to use this table right away without having to subtract, because the table gives areas to the left, less than. Now, we are going to look for the z-score that corresponds to an area of 0.9500. So we look for 0.9500. 0.9500. 9500. 9495. So we see there's a problem here. Okay, we don't see 0.9500. We do not. Okay, we do not see that. So what are we going to do? Okay, this is what we're gonna do. Anything you don't see like that, you have to use interpolation method to find it. Now, some of you might suck at interpolation method, but I'm gonna, let's go ahead. We've done interpolation method here. So please view this video to understand what interpolation method mean. Okay, I will still put more anyway. So we are going to use the interpolation method because we do not see the actual area 0.9500. We do not see it, and we need to find it. We don't see it. So first of all, we have to interpolate between these two values here, between 0.9495 and between 0.9505. So I'm gonna add page here, normal distribution, and don't worry, we will not use interpolation method all the time. Just I want to explain this first. Okay, so we're gonna interpolate this. Let's have this as a z-score, that we are looking for, and let's have this as a probability, okay, or area. Now we didn't see 0.9500, and that's why we didn't see it. But we saw 0.9495 And that corresponds to a z-score of 1.64. 1.64. So that's the lower one, 9495, 9495, and that corresponds to z-score of 1.64. Okay. Then we don't know this z-score here, so let's just call it z because we don't know it. We have to interpolate between these two values. And please, if you don't understand what I am doing now, please view the videos on interpolation method. The other value is 0.9505 and it corresponds to a z-score of 1.65. 0.9505. Okay. So 0.9505. Okay. And that is 1.65. Now, we go ahead and use our interpolation method. We see that z minus 1.64 all over 1.65 minus 1.64 is equal to 0.9500 9500 minus 0.9495 I hope you're seeing this. 49595. Okay, you see that? All over 0.9505 0.9505 minus 0.9495 9495. Okay, so we have done this interpolation method before, so let's save time. Let us kind of save time. So we see that 0.9500 minus 0.9495, that gives us 0.0005. So you might want to write it down. You might want to write it down somewhere. 0.0005. Okay. 0.0005. Okay. Then 0.9505 minus 0.9495. That is 0.001. 0.001. So to save time, we'll just because it will be good if you view those two videos I've done already, so you will understand what I'm doing now. So 1.65 minus 1.64 will give us this 0.01 multiplied by 0.0005 equal to this, then divided by 0.001 equal to this, then plus 1.64. Okay, so this gives us 1.645. All right, some of you might be mad at me and say, Mr. C, why did you waste all this time? Why couldn't you have just added this and divided by 2? Okay, now listen up, folks. We don't do it that way. We don't. We have to do it the proper way, which is the interpolation method. Because some people will say, hey, add this and divide by 2. Okay? We don't do it that way. We do it by interpolation method this way. Okay. And then we want the z to be 2 decimal places. And 2 decimal places means that this will be 1.65. Okay? Now, the answer is 1.65, of course. 1.65. Okay. Now, some of you might say, hey, why did you waste time though? Because you would have just tried 1.64. And then if it didn't work, of course, it's going to be 1.65. After all, these scores are 2 decimal places anyway. Well, yes, but that is trial and we don't want trial and error in statistics. We don't want that. You keep trying. If it doesn't work here, you try this one. No, we don't want to do that. I want you to know interpolation method, and that was why I used it. But there is, but see another thing you can do. Because of the fact that these scores are rounded to 2 decimal places, you're kind of lucky here. You want one thing you can do is this. To save time, this is what you can do. You could, let's call this normal distribution, part 5. Okay. You could look at, hey, which of these is closer to, if you look at this, you could say, okay, which of these 2 is closest to this guy, to 0.9500? Which is closest? Is it this guy or this guy? Which one is closest? When you have 0.9500, who is the closest to who is the closest to 0.9500? Is this 0.9495 or is this 0.9505? Okay, so what you could do here is you find the square of the distances between them. Somebody else might say find absolute value of the distance. Okay, we don't want to use absolute values, and we have our reasons why. We have to take the square of the distances take the square of the distance between this and this, and the square of the distance between this and this. Whichever is smaller, then that person is the closest. And because that person is the closest, you can just use the z-score right away. Okay, so we're gonna find the distance, because this is like this. Look at what I'm saying here. If you have 0.9500, okay, here you have 0.9495, and here you have 0.9505. 0.9505. Okay, so what I'm saying is, let's find the distance between this and this. Okay, let's find the distance between this and this, and also find the distance between this and this. Actually, we are finding the square of the distances, so we can get a positive value. Okay, then whichever is closest, whichever is closest, okay, then we take that as our z-score. Okay, so you just do 0.9500 minus 0.9505. 9495, square it, because some people will add this minus this and it will give you negative. So it doesn't matter, if you square it, it will turn to be positive. And then we also have 0.9505 minus 0.9500, square it. Okay, and the smallest one is their closest. Okay, so we do 0.9500 minus 0.9495, square it. So this is a 2.5 times 1, 2, 3, 4, 5, 6, 7. Okay, let me store this as memory. Let me save it as memory. Then I have 0.9505 minus 0.95, square it. So it gave us the same thing. Both are equidistant. Okay, in this case, both are equidistant. So because they are equidistant, it doesn't matter if you now do 1.64. If you now do 1.64 plus 1.65 divided by 2, because they are equidistant, it doesn't matter. Now, if they are not equidistant, do not do it. Use interpolation. Interpolation is the safest way. The safest way. Okay? 1.64 plus 1.65 divided by 2. That gives you 1.645. You round it to 2 decimal places. It gives you 1.65. That is how you get your z-score. Does that make sense? Comprendez? Comprenez-vous? Okay. 12th percentile. 12th percentile. So here, of course, this is, of course, the 12th percentile because it's the bottom 12 from the top 88. Now, some of you might say, what about this? Well, this looks like bottom 88 from the top 12, see, because this area is bigger than this area, okay? But 88% is bigger than 12%. So that's the way we look at it, okay? So that's this. Now, we look for 12% is 0.12. So we look for 0.1200. Okay, we look for 0.1200 in the area. 0.1200. 0.1200. So you see, we don't have 0.1200. We do not. 0.1200. We don't. But we do have 0.1210 and 0.1190. Okay? We don't have 0.1200. But what we do have is we have 0.1210, okay, and 0.1190. So let's go, and 0.1210 is negative 1.17, okay, and 0.1190 is negative 1.18. So let's now do this. 0.1200 minus 0.1210. And I know you might say, hey, why do you subtract it that way? That's fine. We will square it anyway. Although, let me do it well. Let me go ahead and delete this memory. Delete the memory. So, okay. Now, we do 0.1200 minus 0.1190 equal to this, square it. Okay, so this is 0.000001. I put this in memory and save it. Then I have 0.1210 minus 0.12. That is 0.001. Square it. So this is 1, 2, 3, 4, 5, 6. Recall memory recall. 1, 2, 3, 4, 5, 6. So you see, both of them are equidistant. And because they're equidistant, we can now do negative 1.17 plus negative 1.18. Okay, you can have 1.17, negative 1.17 plus 1.18, negative 1.18. So that gives you negative 2.35 divided by 2. So negative 1.18. If we round it to 2 decimal places. Okay, negative 1.18. So this will be negative 1.18. Okay. Question 23. Assume that the readings on the thermometers are normally distributed with a mean of 0 degree and standard deviation of 1.00 degrees Celsius. So mean of 0, standard deviation of 1, we are good. Okay, assume 2.9% of the thermometers are rejected because they have readings that are too high, and another 2.9% are rejected because they have readings that are too low. Draw a sketch and find the two readings that are cutoff values separating the rejected thermometers from the others. So 2.9% are rejected because they are too high, and another 2.9% are rejected because they are too low. So let us draw this first. Let's go ahead and draw it. Add another page. Normal distribution, part 6. Okay, so if we draw this, this is what it kind of shows. 2.9%, so that's the area. Remember, area can also be in percent, or probability, it can be in percent. Our mean is 0. Okay, our mean is 0 degrees Celsius. 0 degrees Celsius. Now, 2.9% are rejected because they have readings that are too high. So it's going to be like here, too high. This area right here, you see? This area right here. And another 2.9%. Now, this is 0.029. Okay, 2.9 divided by 100. 0.029. To the right. Also, another 2.9% are rejected because they have readings that are too low. So 2.9% here are rejected. Too low. Okay. Draw it because these are readings that are too low. These are readings that are too high. So this is the acceptable region here. This is acceptable region. Acceptable region. Acceptable region. Okay, it's very important, this what we are doing now, because it's very important in statistics when we do hypothesis testing. Okay, reject readings that are too low or readings that are too high. So draw a sketch, so the sketch, we are looking for the region in which they are rejected. So these are the rejection region. This region is rejection region, and this is rejection region. Rejection region, rejection region. And that is what they want. Okay, so it's going to be this right here. Okay. Now, what are the cutoff values? So we are going to find the z-scores corresponding to 0.029 on the left area. Okay. And guess what? Once we find it, it's going to give us a negative value. Okay. The z-scores will give us a negative value, and once it gives us a negative value, the positive value of that will be for this one. Okay, so this will be a negative z-score. It's going to be a negative z-score. We find it, and just the positive value will now be this region. Okay, so let's go and find 0.029. We come over here, 0.029, 0.029, 0.029, 0.029. So 25, 26, 27, 28, 28. So this is 0.0287, okay, and this is 0.0294. So we have 0.0287 and we have 0.0294. This is what we have here. We have 0.029. Here we have 0.0294, and we have 0.0287. Okay, so let's find the square of the distances. So 0.029 minus 0.0287. This is 290, of course, you know that, right? Okay. So this gives us 0.0003. Let me change this memory and put in a new memory. Okay. Hey, I need to square it. So I change this, then I square this first, square it, and I put this as my new memory. Then let me find 0.0294 minus 0.029. That gives me this, okay? So you see now, and if I square this, this gives me, this is not equidistant at all. It's not equidistant. This gives me 0.1234567 7. 1 2 3 4 5 6 7. So this one gives me 1.6 times 1.6 times 10 to the power negative 7. Okay, 1 2 3 4 5 6 7. And this one gives me, recall memory, this one gives me 9 times 10 to the power negative 1 2 3 4 5 6 7 8. So which one do you think is which one is the closest? This is the closest here. This is the closest right here. Okay, this is the smallest. This is the smallest distance. So if we compare these two distances right here, we see that this is bigger than this. So we're gonna use this, okay, because this is bigger than this. We're looking for the smallest square of the distances between them. So this is closer to this than this. So we're going to use 0.0287. Now, what was the z-score that corresponded to 0.0287? 0.0287. It was negative 1.90. Negative 1.90. So that is what we are going to use. Okay. Negative 1.90. They want us to use two decimal places. Comma. They use a comma to separate answers as needed. And then 1.90. Because 1 is going to be the negative. Okay. And this one is just the positive of, because it's the same area. It's the same area, which is 0.0290. The only thing is that this one is negative and this one is going to be positive. Please view that critical Z, the interpolation method critical Z, so that you can understand what I just said here. Okay. So that's the answer. Okay. We have some more questions to go. I know this video is getting long, but I hope you are learning. Now, this is critical value. Okay, critical value. And I just mentioned critical Z. Please, I did this video here. Interpolation method, critical Z. Important, please view it. But let's go ahead and do this. Critical Z, what this means is find the z-score that corresponds to 0.09 area or 0.09 probability of 0.09 to the right. Again, this means find the z-score that corresponds to a probability of 9% to the right. In the right tail in the right tail of the distribution. Excuse me. In the right tail of the distribution. Where did this go? Ooh. This kind of funny. Okay. Now, this is what this means, folks. Look up. This is what it's saying. That question is saying in the right tail. Let me add another page. Normal distribution. I think my notebook is acting up, so it's kind of time to go. My notebook is protesting, which means, Mr. C, time to go. Okay. Okay, we will soon be done. This is what this is saying is the critical value there is find the area that corresponds here to the right, 0.09. Okay, that is what they are asking you for. 0.09 to the right. Okay. Let us see. Let's, first we can find the one that corresponds to the left first. And then it gives us the one that corresponds to the left. We can find that. We have a negative value. Okay, this here is 0.09. Now we are being asked to find critical value, which means to the right. But we can find the one that corresponds to the left. It gives us a negative value, and the positive value will just be the one to the right. So let's look for this here, 0.090. 0.090. So we have 0.0901 and we have 0.0885. So we have these two here. We don't have 0.0900. Okay, so which one do we take? Let us find which one is closest. So we're gonna let me move this. Let me clear the memory and clear the calculator, which I just did. We will do 0.09 minus 0.0885. Okay. This is 0.0015. Square it. It gave me this. Let me put this in memory. Store the memory. And then I do 0.0901 minus 0.09. Square it. So here I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I have here 10 to the negative 8. If you want to say 1 times, that's fine. That's up to you. Now, and the other one, recall memory, I have a 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 2.25. 2.25 times 10 to negative 6. Of course, now, you could easily tell which one is smaller. Which one do you think is smaller? Of course, it's this one is smaller. Okay, so we choose this guy here. Choose him. What was the z-score corresponding to that? That was 0.0. Yeah, this is it. 0.0901, and that was negative 1.34. Negative 1.34. So look at what happens, folks. This is negative 1.34. Negative 1.34. So that tells you now that the z is going to be 1.34. Okay? That is what it tells you. That the z will be 1.34. Okay? So this is 1.34. That's it. Okay, question 25. It says here, find the indicated area under the curve of the standard normal distribution, then convert it to a percentage and fill in the blank. Okay, so about what percent of the area is between negative 2.2 and 2.2 standard deviations of the mean. Now, when you look at this, here we find the z-score. This is what they want to ask us about. Okay, for the z-score of negative 2.2, okay, and the z-score of 2.2. This is what they're asking us about. What percent of the area is between? So this is the area they are asking us for. This area right here. Okay. Now remember what we said. We have to, because we are using this table that is on the left. The area is on the left. So we find for 2.2. Also, we find for negative 2.2. Then we subtract. Okay? And they want us to round to 2 decimal places. Convert it to percentage. Okay? So let's find for 2.2. 2.20. That is what it means. 2.20. So that is 2.2 under 0. And that is... let me clear this memory. Clear this also. So 2.2 under 0 is 0.9861. Okay? 0.9861 minus negative 2.2. Negative 2.2 under 0 is 0.0139. 0.0139 equal to, so that is 0.9722. Convert it to percentage is, of course, 97.22%. Okay, and the 1 is to 2 decimal places, so this is 97.22. That's it. Normal distribution. 3 more questions, then we call it a night. Part 8. Okay, now the next question is the next question here is find the area under left of z to be -2 and right an area under right of z to be 2. So, okay, this one is, pretty straightforward. I want you to do this yourself and then we'll do it together. Next one, find the area under left of z to be -1.59 and area under right of z to be 2.59. Then the last one, find the area under left of z to be -0.25 and area under right of z to be 1.40. Okay, add these areas. Find the sum of these areas, or add these areas. Okay. Let's just do this and then we will stop here and do more in subsequent videos. Okay, so the first one is, this is the area they are asking us for. And this is for the standard normal distribution table. So left of z, -2, and right of z, 2. Okay. So it's just these areas, these 2 areas here. Okay. And I think we've done this, so it's like a repetition. But that's fine. I think we did for -2.2. Well, no, we didn't do it. This is not it. This is like 8 here. This here. This is 0.029. But anyway, let's find the area, this area here. And of course, this area is going to be equal to this area. Okay, because this is -2 here and this is 2. This is symmetrical about the mean. Okay, well, that's one of the properties of the normal distribution table. It's symmetrical about the mean. And for a standard normal curve, the mean is 0. Let's now find for z to be -2.000. Okay, and once we find it, we multiply by 2 right away. So we're going to use our table. -2.000. Sorry, did I say negative? Yeah, -2.00. -2.00. Okay, -2.00. -2.0 on 0. So do you see this? So this is 0.0228. 0.0228. Okay, so that is what this area is. 0.0228. And this is still the same area here. Okay, 0.0228. So 0.0228 times 2. And that gives you 0.0456. That is the answer. 0.0456. 0.0456. Does that make sense? Okay. Second question. Area under this. Because you're asked to add these areas. So area under negative 1.59 should be around here. Negative 1.59. And then right is 2.59. Kind of put it right here. 2.59. So in this case, this is not symmetrical, no, at all. Now this is symmetrical because this is negative 2 and this is 2. The areas are the same. But this is not symmetrical at all, no. So we have to find this separately. They want us to find this area right here. Okay. And they want us to find this area right here. Okay. Now, we can easily find this area. That's not a problem. Another thing we could do is, to find this area, we could just find, okay, to make it easier for us, we could find this area right here. This area right here. Okay. As negative 2.59. Negative 2.59. Because this area is going to be this area here. Okay. Now this is symmetrical. This is negative 2. This is 2. So that's fine. Now to find this, we find this area first. We keep it. And then we find this area. And then it will be symmetrical. Now, this is one way to find it. We have another way to do this, okay? But this is an easier way to do it. I can explain the other way if you want me to, okay? Just put in comment. Mr. C, explain the other way. But this is the easiest way. So let's find this and let's find this. It's the same area as this, okay? Then we add it up. So we get our standard normal distribution table. We have negative 1.59, and that is this, negative 1.59, which is 0.0559, plus we have negative 2.59, negative 2.59, and that is 0.0048. 0.0048 equals. So that gives us what? 0.0607. 0.0607. 0.0607. So here, the third one, what do? We just find negative 0.25, and we also find what? Negative 1.40, and we add it up, okay? So we have negative 0.25, negative 0.2 under 0.05, 0, 1, 2, 3, 4, 5, 0.4013. 0.4013 plus negative 1.40 is 0.0808. 0.0808. And that gives us negative 4.821. Okay. So that gives us 0.4821. That gives us 0.4821 or 48.21%. Okay, we are going to stop here for tonight, okay, and we will continue next time. Thank you so much for listening and staying with me. And you have a good evening.